Function recursion. Today we'll learn about recursion. We'll take an example and then talk about its pros and cons and take more examples. Recursion, noun, is the repeated application of a recursive procedure or definition according to the Oxford English Dictionary. Notice the recursion in the definition itself. In simple terms, recursion is to define a word in terms of itself. A human baby is a human within another. So is a gift box within another. In Python, a function calling itself is recursion. Let's take an example. Let's build a factorial function. This has a base condition and a statement that alters the value of a variable to avoid an infinite loop. This code keeps altering the value of res while num is greater than 0. Factorial of 5 gives us 120. But this wasn't recursion. Recursion is when a function calls itself. Let's rewrite this. This is the base condition. This function stops and returns 1 when num is 1. If it isn't, it returns num multiplied by whatever is returned by a call to this function with a value of num minus 1. Factorial of 5 gives us 120. So how does this work? Factorial of 5 is equal to 5 into factorial of 4. This is equal to 5 into 4 into factorial of 3. This is equal to 5 into 4 into 3 into factorial of 2. This is equal to 5 into 4 into 3 into 2 into factorial of 1, because factorial of 2 is 2 into factorial of 1. Now factorial of 1 is 1, so this makes it 5 into 4 into 3 into 2 into 1. This is equal to 5 into 4 into 3 into 2. 3 into 2 is 6, so this is equal to 5 into 4 into 6. Now 4 into 6 is 24, so we get 5 into 24. This is equal to 120, hence the output. Now if you begin with a negative value, you cause a recursion error since the if condition is never met anyway. Factorial of minus 5, it says it has reached the maximum recursion depth. It's also possible to run into this issue if you forget to provide a base condition for the recursion. This code does not state a base condition. Does recursion help or does it hurt? First, recursive code is cleaner. Recursion leads to smaller code and this is easier to read. And while it is so, it may still be hard to follow. A recursive function isn't as easy to understand as an if statement. Recursion also makes it easier to code since it breaks down tasks into smaller ones. Each call to the function performs a subtask. But recursive calls are expensive compared to iteration. There's the overhead of method calls, and recursion also requires the allocation of a new stack frame. They take up a lot of time and memory. If you need to generate a sequence, recursion will do a better job than will nested iteration. However, recursion is not so easy to debug. Let's take one more example. Let's calculate the sum of the first n natural numbers. The base case says the function exhausts on the value of 1 for none. The function returns num plus the result of a call to the function with num minus 1 as argument. When we then make a call to this function with the value 7, the output is 28. Let's break it down. A call to this function with the value of 7 gives us 7 plus sum n of 6. This is the same as 7 plus 6 plus sum n of 5, which is 7 plus 6 plus 5 plus sum n of 4. This is equal to 7 plus 6 plus 5 plus 4 plus sum n of 3. And this is 7 plus 6 plus 5 plus 4 plus 3 plus sum n of 2. This is equal to 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus sum n of 1. Sum n of 1 follows the base case, so this means it returns 1. This means we now have 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1. 2 plus 1 is 3. 3 plus 3 is 6. 4 plus 6 is 10. 5 plus 10 is 15. 6 plus 15 is 21. And 7 plus 21 is 28. This happens in the exact order we described it here. It cannot simply add all from 7 to 1 at once. It returns values to parent calls one at a time. To say it again, recursion is a useful tool when you want to perform the same thing but with different values and in a sequence.